What's up everyone guys, my name is Victor Basu and welcome to my channel Windows Victor. So today I am going to talk about some of the AI image processing algorithm that has really been the backbone of most of our modern innovations. Now there are various types of AI image processing algorithms. Some of them are generative and some of them just are used for processing. But I am going to discuss two of the most widely used and are most popular among these algorithms that are used in our modern innovations. First of all, we have the GAN, Generative Adversarial Network. Now what is this GAN? Now this GAN is basically a combination of two neural network algorithms. The first neural network is called a generator and the second neural network is called a discriminator. Now generator creates new data instances. Now these data instances are real or not, or whether how much real are they, is authenticated by the discriminator algorithm. Means this discriminator algorithm, what it does is that it takes the instances from the data instances from the generator algorithm and it checks that how much real it is with respect to the training data set, means whether it belongs to the training data set or not, and classifies it as a real or fake. Now for example, the GAN algorithm has to create a fake image of an original image. Now how it will work is that the generator algorithm would create a synthetic image out of nowhere. Then this image would be fed to the discriminator algorithm, and the discriminator algorithm will check how much real it is with compared to the original image. Now it would first classify how much, whether it is real or not, and if it is not real, the discriminator algorithm would again fetch that synthetic image back to the generator algorithm. Now this generator algorithm will again try to make it as real as possible. Now the generator algorithm would again try to create a more realistic image compared to its previous performance. Means it would again fetch the image to the discriminator in the hope that it would be authenticated by the discriminator algorithm, although the image created by the generator is totally a fake image. Now this whole feedback cycle continues until and unless the discriminator algorithm finally authenticates the image created by the generator. So like this, a whole new fake image which is totally a copy of the original image is formed. Now to see it from a mathematical point of view, how the GAN algorithm actually works is that at first the generator algorithm generates some random number in the form of a matrix and returns an image. Now this generated image is fed into the discriminator algorithm alongside with a real and original image that is taken from the original data set. Now the discriminator algorithm compares between the real image and the generated image, and it returns a score between 0 and 1, where 0 means a completely fake image and 1 means a completely real image. So the scoring the score is actually the probability of being a fake, or a real image. So like this, the discriminator algorithm is in a feedback loop with the ground truth image from the original dataset, and the generator algorithm is in a feedback loop with the discriminator algorithm. So like this, both this discriminator algorithm and the generator algorithm is in a constant learning phase. Means with each iterations, these two algorithms are constantly learning, and their main objective is to create a whole new fake image which is a duplicate of the original one. So that's how GAN actually works. Now secondly, we have this style transfer algorithm. Now this style transfer algorithm is not actually a generative algorithm, I would say. Means it generates a whole new image, but not like a generator algorithm, it actually works. Now style transfer is a technique of recomposing an image with the style of another image. Now how is this style transfer algorithm actually working? Here, a convolutional neural network that could classify between different images is passed through a optimization technique. Now, after passing through the optimization technique, it finds pattern between input images rather than its own weights. Now, our main objective is not to classify in this style transfer algorithm. Rather, our main objective is to transform a whole, means two images, into a whole new image. So actually what we do, means what is done in the style transfer algorithm is that, so we will frame the style transfer task as a optimization problem by including a loss function whose main objective is to minimize the error in the whole neural networks while generating a new image. Now here we have two kinds of losses. One is the style loss and another is the content loss. Now I would not go much deep into it because means the style loss and the content loss, all these are more complex things from mathematical point of view, and means how is this whole image transformed by creating matrix and gram matrix and the use of Euclidean distance. Because I don't know whether you are familiar with machine learning and deep learning or not. So if you want to know more about it, you can Google it out and check from the mathematical point of view how it uses the style loss and this content loss, and how use these simple mathematical formulas like Euclidean distance to generate a whole new image through this style transfer algorithm. Now this style transfer algorithm is used by Google Stadia also. Now Google has brought a remarkable change in the world of gaming by introducing Google Stadia, where you don't need any graphics card or highly professional laptop or gaming laptops to play games. Rather, you just need to have a Stadia subscription, just like the Netflix subscription, or a Stadia gaming joysticks to play a game. Means it is a whole new innovation. Now this part of the Google Stadia, that you don't need means any hardware acceleration to play games, just you need to have a subscription to play a game, is known to everyone. But there is another side of Google Stadia, that is, it has also brought a remarkable development for the game developers also. Now what they have done is that they have included this style transfer machine learning algorithm for the game developers, so that they can bring out their artistic idea while developing games. If you go through the whole conference of this whole conference set up by Google during this introduction or launching of Google Stadia, you would see that the first part was explanation of how Google Stadia was going to bring a remarkable change for the gamers, and the second part was actually at the middle, I would say, there was actually a part they explained how Google Stadia is also going to bring a remarkable change for the game developers also. There they introduced this style transfer machine learning algorithm, where the developers could bring out their artistic mind to create and develop games very easily and very fast. They don't need much of a blending technique. Now this GAN algorithm and style transfer algorithm also has the power to create a fake face which has no existence in this real world. Now as per the scientist and researcher from NVIDIA, they have stated that this GAN algorithm and style transfer algorithm could actually create a face image of a face that has no existence in this actual world. Their theory is that if you train these models, this style transfer algorithm and the GAN algorithm, with a lot of facial image or images of different persons, then these models have the power to generate a whole new face that you have never seen in the real world. Suppose this GAN algorithm, it is wholly a generative algorithm, as I have told before. If you train this model with a lot of faces, images of a lot of face, then it could generate a whole new face that has no real existence. Similarly, in case of style transfer algorithm also, I have discussed before how it works. Now Here what it does is that it takes the features or the traits from different faces, means the skin color, the hair color, the skin tone, and this means eyes and nose from different images, and try to blend out a whole new face, means a whole new facial image. So like this style transfer algorithm is also used to create a new face. Now you might be thinking that these fake faces which are generated could be used for malpractices and misinformation in the real world, and it could create a great chaos if by using a fake face, means image of a fake face. Actually you are wrong at it. This algorithm does have a great disadvantage for understanding the symmetry of a human face, means they could blend out a whole new image or generate a whole new image, but in case of understanding the symmetry of the face they are a bit weak, means these algorithms are a bit weak for understanding the symmetries, means the fake faces or the image of the fake faces which are generated, actually if you look closely then the ears are not actually symmetric, or might be the eyes, the placement of the eyes are not symmetric. Maybe the hair that you are that is the part that is created in the image is means combination of two hairstyles, means you could easily understand that it is a fake image if you watch it closely. This algorithm does have the disadvantage of not understanding the symmetry. Now at last we have the first ever image of a black hole. Now you might be thinking that this image of a black hole is taken by the telescopes or 7 different telescopes that are scattered all around the world. Actually it is not. A whole image processing algorithm is the backbone behind this creation of the first image of a black hole. Now what this telescope did was that it tracked the light emitted or the light around the black hole. Now these measurements or the lights which are tracked by these 7 different telescopes are recorded. Now by just tracking the lights around the stars of a black hole is not enough measurement to create the whole image of a black hole. As the earth rotated, the scientists saw a whole new measurements, as if you are having a picture and you are means a unseen part of the picture is coming in front of your eyes. Now all these measurements taken by these telescopes generated a incomplete image, means a incomplete measurement to generate the image of a black hole. Now these measurements are passed to the image processing algorithm, which is blended with the equation on Einstein's theory of relativity. Now this image processing algorithm reconstructed the whole image by filling up the missing gaps or the missing measurements, which must be a necessary part to create the whole image of a black hole. Means these 7 telescopes or the light tracked or the measurement taken by the telescopes are not enough to create the whole image. Now this image processing algorithm reconstructed and generated the missing values that must be present between those measurements taken by the telescope to generate the whole image of a black hole. So this is how different image processing algorithms or AI image generating algorithms are the backbone of most of our modern innovations. So I hope you guys enjoyed this video. Please don't forget to hit the like button and please share it among all your friends, and do not forget to subscribe to my channel. Please subscribe to Windows Victor. Till then, thank you very much.